Okay. So we're talking about the second of our 4 translations, or transformations, I should say. This one is called a reflection. So a reflection across a line M, called the line of reflection. This dashed line here is the line of reflection. It's what we're folding the shape over. Is a transformation with the following properties. And this is important. You've got to pay attention to this. And ask an example on this in just a few minutes. See this point A right here in the black shape on mine? When I reflect this black triangle over line M, the red line M here, and get the blue triangle, notice what happens to A. A was on the line of symmetry, and look at the new A prime. We're going to use a little prime for the image. Okay, the pre-image will not have little primes on it, little ones, and the image will. So notice that A stays right at the same spot. And then B, what they're demonstrating here, is the same distance away from the line of symmetry here as it is here. They actually say this is the perpendicular bisector. Same thing with C. Now, we do have some new notation. It says you write the reflection across M that takes P to P prime as R of M, Rm of P equals P prime. So they wrote it like this: R subscript M of P equals P prime. So this is saying the reflection of point P about line M is P prime. And today we're going to be primarily reflecting over horizontal and vertical lines. If you look at your outline here, learning objectives, there's just one learning objective for reflections. It says, I can reflect the image of a figure over horizontal or vertical lines. Bonus if you can do it over diagonal lines, I guess. But primarily we're focusing on just on the coordinate plane, you can reflect a shape over a horizontal line, which has the equation of what? Horizontal lines are the y equals or x equals lines. Y equals lines. And vertical lines are x equals lines. So that's the primary learning objective today, is you can reflect a point or a shape over a horizontal and vertical line. Okay? Sounds easy, right? I thought I'd start with the generic definition here, besides reflection. Line of symmetry is a line over which a shape is reflected. So people are very symmetric. There's an imaginary line of symmetry that kind of goes right down, vertically down your body, right through between your eyes, through your nose. And you know, we're generally symmetric, some maybe more than others. But yeah, I'm not either. My right foot's a little longer than my left, but we're close to symmetric. So I thought I'd ask you here, give you just a minute here. Do you guys understand the idea of a line of symmetry? It splits the shape in half so you can fold one side over the other, and it would match up perfectly. There should be no rotation or sliding at all. It's just a perfect fold over, match up perfectly. So go ahead and try A, B, and C here. I'd like you to see how many lines of symmetry you can find for each one. I'm going to have somebody come up here and draw them. Go ahead and look at A right now. See how many lines of symmetry you can draw there. Now make sure you can fold the shape over and it will match up perfectly. They have to be straight lines. I have to see what you're doing. I'm sure. Let's do it. Let's do it. Fold this over. Does everybody try out? Does everybody try and draw in? Is that what we do? Call it quick. Insert section 2. Drawing lines. And symmetry. So did anybody find any more than 2? On which one? Number 1. Part A, I guess. Somebody come up and draw the 2. You're going to draw. You can point up and draw. There's only 2, right? There's only 2 that I can think of. Yeah, did anybody find any more?
Yeah.
So look at your neighbors here. I see some of you. Did we find more than 2?
Yeah.
Sure. Hold this over here. So I think this is it. What about on B? Try B for right now. That would mean this would fold over that.
What's in the center? Is that a doctor or something?
What's in the center? This is a doctor, yeah. How many lines of symmetry does this figure have?
1.
Careful.
2. Right.
Why not?
Oh.
It's 2 dots.
For the 5. There's 5 on it. There were 6.
Oh, there's this pen.
This is really an interactive lesson here. Yeah, do you see the pens in his pocket?
I had a feeling.
So if the pens weren't in his pocket, how many would it have?
1.
Right. What about C? Go ahead and try C. Do it in pencil. You got it already? Okay, just wait. I can tell you it does have lines of symmetry. More than 1.
No, I got 7. That's like a lot. Oh, I got it.
Try it. See if you can find a good pencil just in case. But yeah, we had 2 on this one. 0 on this one.
I hate those words.
Give everybody a chance to try it. All right. Somebody want to come up and draw them?
Is there like a
Go for it, Jesse. You go for it. How many do you have? Now, can you fold this? Just make sure you can fold it over.
Oh, I get it.
Okay, good.
Wow.
Did we get them in? So did we get 5 then?
Yeah.
Good. Good. So lines of symmetry show up in life all over the place.
Sorry.
All right. Here's why you have to understand that x equals lines are vertical and y equals lines are horizontal. Here's what comes into play. We're going to graph the given reflection, given the coordinates of the reflection. This is kind of a little typo here, but it's capital letter R means reflection. We're going to use lowercase letter r for rotations. And the subscript there tells you what you're reflecting it over. It will either be a horizontal or vertical line, primarily in this lesson. And then what you're going to go ahead and reflect. It could be a point, it could be a line segment, it could be a triangle, any shape that we've studied so far. Okay. So if I take H and plot it, H is at 2, 2, so go ahead and do that with me. Here's H. We're going to find H prime. And we're going to reflect it over the x-axis, which is this horizontal axis right here. Really easy to do. What the properties of reflections, when we looked at that first little box, said if it's on the line, it stays there. If it's not on the line, it's got to be the same distance from the line on this side as it is on the other side. So we're going to go 1, 2 here, and then 1, 2 down here, and here's my H prime. So that is reflecting over the x-axis. It's 2 units away from the green line here and 2 units away here. So we are at the coordinate 2, -2. So the reflection in the x-axis of point H will be 2, -2. So notice, notice some things here. The x value stayed the same. The y value changed. It's the same distance away there. So reflection over the x-axis, pretty easy to do. Y-axis, the same thing. So any questions on that? Try the other 2 here. I think I might go ahead and you can just do it all in the same way. I'm going to erase this. All right, so I have 5, 4, which is right here. We're going to call that G. So there's 5, 4 at G. And I'm going to reflect this over the line y equals 4. What's that? No, we don't add 4 more. It's not like a translation. We're going to draw the line y equals 4. Do you know what the line y equals 4 looks like?
Wait,
Oh.
Go over 5 and up row. Am I off? I am off by 1. Sorry. So it's right here.
over.
So there's G right there at 5, 4. I'm going to draw the line y equals 4. It's a horizontal line. But it goes right through the point. So when I reflect G over this line, where is it going to be? Exact same spot. Yeah, G prime is in exactly the same spot. So this ends up being 5, 4. And that was one of the properties in that little box up there at the top. If the point is on the line of symmetry, when you flip it or reflect it, it will stay there.
So they're just right.
So there is no difference.
Okay, well, it just, when we do a reflection, okay, if the point is on the line of symmetry, it's going to stay there. If the point, like in this one, is off the line of symmetry, it's going to stay the same distance away from the line of symmetry on the other side as it was on the original side. That's it.
How do you know this on the line?
You draw the picture. You have to draw. So I drew the line of symmetry y equals 4. I plotted the point 5, 4 on the side. So with the picture, I'm going to give you a graphic. Okay, let's try another one where it's not right on the line. You maybe missed that one, Josh. So take J, 1, 0. We're going to plot J at 1, 0. So there's J. We're going to find J prime. So x equals -1. Where's that going to be? Draw it in the sky. Is it vertical or horizontal? Vertical. So it's going through x equals -1 right here. So real easy here. You got to watch carefully though, because it happens quickly. How far away is this? So on the other side, when I fold it over, reflect it over, it's going to be 1, 2 over here. So 1, 2, 1, 2. Here's my J prime. What's the coordinate of J prime? -3, 0. Real easy to do. Just counting distance.
How come on the H1 you didn't draw the line? Why is it anything? So if you only draw the line, it's on it.
I drew the line on each one. You mean the line of symmetry?
Yeah. Well,
Yeah, I did. I drew it on this one. Maybe you didn't see it because it was right on the x-axis. Yeah, but I
I
did.
don't know what you just said at all.
Okay.
When you want
Okay. X. All I do is I plot the point at 1, 0. I draw the vertical line x equals -1. That's usually the confusion. That's an algebra thing. X equals -1 is a line here. A reflection of J over this line will put it the same distance on the other side. I'm folding it over. I'm counting over. That's it. All right, any other questions on this? All right. This is example 3. Use the information to sketch the image of triangle ABC after each reflection. So we're going to draw a triangle and then reflect it. So triangle ABC is at -3, -2. That's A. B is -5, -1. And C is -4, -5. So there's triangle ABC. And the first thing we're going to do is reflect triangle ABC over the x-axis. So here I'm tracing over the x-axis. So can you see my line of symmetry? So right over the top of the x-axis, we're going to reflect it. So I should have, this is a rigid motion, I should have a congruent triangle up above that x-axis when I reflect it. So we're going to apply the same principle that we just used, but for 3 points rather than 1. We'll apply the same principle we just used for 3 points rather than 1. So let's start with B. Where's B prime going to be? How far away from this line?
-5, 1.
It'll be at -5, 1. It'll be so there's B prime. It's 1 away from the line of symmetry. Where will A be?
-3, 2.
Yeah, -3, 2. Where will C prime be?
-4.
So we count 1.
-4 and 5.
It's 1, 2, 3, 4, 5. So it's going to be 1, 2, 3, 4, 5 up. So you can just stay in the same vertical line here.
See 5 up.
5 up because 1, 2, 3, 4. It's 5 below on this side. 5 up. So that is the reflection over the x-axis of this shape. I'm going to switch colors here. And I'm going to make a reflection of triangle ABC over the line y equals -1 next. So I have, I might go ahead and erase that. Are we okay with this one?
Is that what we do?
I had, that's it, for this first part. So I'm going to erase this. Go ahead and use my green triangle here. You're going to have to do it on, I have 2 on the same graph for yours. What's that? So there's triangle ABC. Now I'm going to reflect this over the line y equals -1. What's that? Don't erase it. Just go ahead and do it, put it on the same graph. So here's the line y equals -1.
We just leave it. We use that.
I can do it on the same graph too if you're confused. It's fine. So I have -3, -2. I just thought it might be easier for you to see. But we can try it. -5, -1. Yeah, -5, 4, -5. You know, it'll just be overlapping. But there's my original triangle, and then I had my reflection over the x-axis. I had a point B prime was here. C prime is up here, and then A prime is here. I'm redoing it. Getting a lot of confusion here. So that was the first reflection I did. Now I'm going to take the same shape ABC and reflect it over the line y equals -1. And I'll go ahead and do this in green. So if I reflect it over this green line, my B is going to stay the same. Yeah. So we'll call this my B prime. And then A, it's a distance of 1 away here, so it's going to be a distance of 1 away over here. This is the second one right here. Reflection over y equals -1. And then C is 4 away, so I'm going to go 1, 2, 3, 4. Just have 2 overlapping triangles. It's a little messy here. Because C is 1, 2, 3, 4 away from the green line here, so C prime has to be 1, 2, 3, 4 above it on the other side.
So you just do it. Wait. So is it still 5 away though? Like C?
No. C is a different, we're doing a different reflection. We're doing a reflection about the line y equals -1. So C is 1, 2, 3, 4 away from that line of C.
Oh, so it's 4 away.
So it's 1, 2, 3, 4 away on the other side. They're going to ask you to do more than one on the same graphic on a couple of these. So it's kind of like that problem where you made the 3-dimensional shapes too, where you did the translation and there's some overlapping stuff going on. So you will have to be able to, I guess, visualize this or use different colors or something. All right. Now we're going to go ahead and reflect over vertical lines here. Okay. So these are reflections over horizontal lines. These are reflections over vertical lines. So I'm going to take the same triangle, -3, -2, -5, -1, and -4, -5. I'm just drawing the same triangle again. This time I'm going to reflect over the y-axis. So the y-axis is this vertical line right here. So if I reflect this shape over the y-axis, I'm just just picture folding it over. How far away is A from this vertical line?
4. No, 3.
Okay, I'll wait. Have the triangle drawn. So how far do I have to go over here from this vertical line? Yeah, 1, 2, 3. So here's my new A prime. How far over for B?
5.
5. So 1, 2, 3, 4, 5. So here's my new B prime. And then where's C going to be? 4 over 1, 2, 3, 4. There's my new C prime. These two shapes are congruent. Just reflected it over that vertical line. So on that same graph, you could draw a new line of symmetry. The second reflection here, x equals 1. Where would x equals 1 be on there? Go ahead and draw x equals 1.
X equals 1.
X equals 1. Go ahead and do this in green. Maybe I should highlight this and do this work. So now I'm going to take
We're not done.
the same triangle ABC.
Wait. He just drew that line. I know, but X is not the other line.
No. X equals 1 is a vertical.
It's not Y.
No.
It's going through.
It goes through the x coordinate of 1. Like if I were to ask you what is the y coordinate, what are the y coordinates for this green line? There's an infinite number of them, right? Like x is always 1 for this. This is 1, 0. This is 1, 1, 1, 2, 1, 3. So x is always 1, but y is changing. So we call it the x equals 1. But it's true.
So just why wouldn't they do it like the x-axis?
Well, it makes sense because x equals 1 is what it's on all the time.
That's true.
This is why I asked those last few problems in the homework. That's why we need to spend a little bit of time on them. Kind of going back to algebra and understanding the equations of vertical and horizontal lines. So to think about it a little bit. So these are x equals lines here and here. What would the equation of this blue line be right here?
Y.
No? Not y. X equals 0, yeah. Okay, so let's take this green triangle now, and we're going to reflect it over the green line. So I'm going to count for A. So watch carefully here. 1, 2, 3, 4. So 1, 2, 3, 4. Here's my new A prime. I probably should call this maybe A double prime or something since I'm doing it on the same way.
How would you do that?
What?
How would you do that?
Double prime? Just put another little apostrophe there. And then C would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here's C prime, double prime. And then B, I think, goes off the grid a bit. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Should be about right here. Then you connect the 3. So you should have a triangle that's the same size as the original triangle, but it's shifted over a bit because we moved the vertical line over a bit, right? All right, any questions on that? All right, some properties of reflections. Reflections preserve distance and angle measure. That's the definition of a rigid motion. Okay, so reflections are transformations that create rigid motion. Reflections map each point of the pre-image to one and only one corresponding point of its image. So when I reflect this triangle ABC over the line M, each point matches up with one and only one other point. Example 4 here. Here's a reflection. Actually, what I want you to do on this one says, Each triangle is a reflection of another triangle across one of the given lines. Can you tell me which of the triangles 1, 3, or 4 has as its image 2 after it has been reflected over one of those two lines? Can you tell?
4.
Looks like it's 4, yeah. And what is 4 being reflected over? So the way we would write this is it's a reflection, capital R, in the line K of triangle 4. So the notation would be a reflection over K of triangle 4 gives me triangle 2. So you could even say equals 2. So speaking of triangle 2, we numbered them because I didn't want to name it with 3 letters. So we're numbering the triangles.